Good morning. Myself Prabha Ramji, working as a assistant professor in EC department at SNL College of Technology. In this lecture video, I am going to discuss about the topic is quantization from the unit 4 finite Bedroom defect in the digital signal processing. Okay, let I discuss. Yeah. The quantization in digital signal processing is a crucial process that converts continuous value signal into discrete values suitable for digital computation. This steps is essential in the digitization of analog signals and enabling their storage, transmission, and processing using digital systems. Okay. The A to D converter consists of a sampler and quantizer. The sampler will sample the value of analog signal at uniform intervals to produce a sequence of unquantized values of the signal. The quantizer will quantize the analog value and produce the corresponding binary codes. The process of assigning binary number to quantized analog value is called coding. This is the A to D converter block diagram. There are three blocks. First one is sampler, and second one is quantizer, and third one is encoding. That means coder. Okay. The sampling process done by using sampler, quantization done by using quantizer. Okay, encoding process is done by using coder. Okay. The input of the sampler is analog signal, which means continuous time signal. Both amplitude and time period is in continuous in manner. The output of the sampler is discrete time signal, which means time is discrete and amplitude is continuous in manner, and quantizer output is discrete both time and amplitude values, and finally we will get the digital signal. Okay, this is the block diagram of A to D converter. Okay. Yeah. In quantization process, sampling, the analog signal is sampled at discrete intervals, typically determined by the Nyquist rate, which is twice the highest frequency present in the signal. Quantization Second step is quantization. Each sampled value is mapped to the nearest value within the finite set of discrete levels. The range of the signal is divided into intervals, each associated with a quantization level, and encoding. The quantized value are then represented in a binary form of digital processing. This is the quantization process. Okay, there are different types of quantization. First one is uniform quantization, and another one is non-uniform quantization. And yeah. The types of error due to the quantization that are produced by A to D conversion process are quantization error and saturation error. There are two types. The quantization error is due to representation of the sampled signal by a fixed number of digital levels. The saturation error occurs when the analog signal is exceed the dynamic range of A to D converter. In analog A to D conversion, when B bit binary codes, including sign bit, is selected, we can generate 2 power B different binary numbers. Okay, and this is a very important one, that is steps quantization step size, which is represented by del or q. Okay. Uh, Q equal to R divided by 2 power B. Which is equal to R divided by 2 power small b minus plus 1. Where capital B is represented by a size of binary including sign bit. Already we see in the first lecture video, sign magnitude is 0 means which is represented by positive represented by 0 bit, and negative represented by 1. Okay. Small b equal to capital B minus 1, size of binary excluding sign bit. Usually the analog signal is scaled such that the magnitude of quantized signal is less than or equal to 1. In such case, the range of analog signal to be quantized is -1 to +1. Therefore, R equal to 2. Quantization error E of n equal to xq of n, which means quantized signal minus unquantized signal x of n. Okay. Uh, Quantization is a fundamental aspect of DSP that converts analog signal into digital form. While it introduces quantization noise, various techniques can mitigate its impact, balancing and trade-off between accuracy, complexity, and resource requirement. Understanding quantization helps in designing efficient DSP systems across a wide range of applications. Yeah, if you have any doubt, you can comment me. We will meet in next video. Thank you.